welcome to lecture number 42 of fuzzy sets, logic and systems and applications. In this lecture, we will discuss some examples on linguistic hedges, and then we will discuss the negation, complement and connectives. So, let us take an example here to understand this better. So, if we have a linguistic variable bright, so we have a bright, and as I already mentioned that this bright is termed as a primary term. This bright basically is a fuzzy value which is represented by a fuzzy set. So, if we have bright, simply bright here, and bright here is a discrete fuzzy set. This is a discrete fuzzy set. So, just to make you understand, we have taken this example. So, let us now convert this fuzzy set here, which is characterized by membership values along with the corresponding generic variable values 1, 2, 3, 4, 5. So, let us now, using the given bright discrete fuzzy set, let us now find very bright and then very, very bright and then more or less bright. So, since we have been given here the primary discrete set, we can write primary discrete fuzzy value or fuzzy set, all these names can be used interchangeably. So, a bright fuzzy set has been given. Now, let us convert this fuzzy set into very bright. So, when let us say we are supposed to use very bright word in order to communicate something. So, how can we make use of this bright fuzzy set, and we can generate a new fuzzy set using the fuzzy set bright for very bright. So, very bright, as I have already mentioned, very, when very word comes here, this means we have to raise the power here by 2 on the membership function, and if it is a discrete fuzzy set, it is all the membership values are squared. So, very bright is very simple to get here. So, since we already have 1 by 1 and then plus 0.8 by 2 plus 0.6 by 3 plus 0.4 by 4 plus 0.2 by 5. So, here what we have to do for very bright is, because we are only adding the adjective very here on the bright, bright is already given. So, this very term has to simply increase the power of increase the membership value, that means we have to square the values of the membership, and let us see what we are getting. So, here we see that we have squared the values, we do not have to touch, we do not have to change its corresponding membership, its corresponding generic variable 1, 2, 3, 4 and 5. We do not have to touch that, we do not have to change these values, we only have to square the values of the membership. So, here we are squaring 1, so 1 will become 1 only, and then 0.8, when we square it we are getting 0.64, and here square of 0.6 will become 0.36. Similarly, square of 0.4 will become 0.16, and then square of 0.2 will become 0.04. So, this way we see that we are getting a new discrete fuzzy set. So, this fuzzy set is a fuzzy set which is for very bright, I can write here this as the discrete fuzzy set for very bright. So, what is interesting here is to note is that we had bright only. We were given the discrete fuzzy set for bright, and here we are converting the bright into very bright. And as I have already discussed, when we add very before any linguistic value, before any primary fuzzy set, so then this bright becomes very bright here by adding very. And since we are adding very, and we have already seen that very comes with squaring of the membership, values are membership function in case of continuous fuzzy set. So, in case the fuzzy set is a discrete fuzzy set, then simply we have to square the respective membership values, but if it is a continuous fuzzy set, then we will have to simply square the continuous membership function that has been given for the primary set. Let us now move to the second example, which is for very, very bright. So, bright has been given to us. Now, we have to convert the given bright discrete fuzzy set into very, very bright. So, obviously, here we have 2 times very, very. So, we have to square it 2 times. We have to square the respective membership values in twice. So, when we square the membership values twice, this the respective membership values basically becomes the original membership values raised to the power 4, which you can see here. This is for very, very. So, when we use the bright and we want to have very, very bright, we this way by taking the powers increased by 4, the powers of the respective membership values by 4, we are getting its membership values like this. And please note that here no change will happen to its corresponding generic variable values, which are 1, 2, 3, 4 and 5. So, we do not have to change these values, only the change will happen to the corresponding membership values. In case of the discrete fuzzy set, simply we take the membership value and we use the membership value raised to the power 4, and then whatever value comes we will write. But if it is a continuous fuzzy set, then the membership function will become the twice square. It means we will write the mu x raised to the power 4. Now, let us quickly go to the third part of the example here, and here the bright is given to us and we have to find the more or less bright. So, more or less is a hedge, as I have already mentioned. So, like we had very and then very, very, very and then extremely like that. Now, let us take more or less as hedge and let us see what happens with more or less. More or less basically we get when we change its membership value, we dilate its membership value, in other words I would say. So, more or less means we rather than squaring or raising the power, we are decreasing the power here. So, decreasing the power means we are taking the square root of the original membership value or membership function. So, in case of the continuous fuzzy set, we simply take the mu x raised to the power 1 by 2, whereas if it is a discrete fuzzy set, we simply take the square root of all the respective membership values. And here also we will not touch any of the generic variable values. So, all the generic variable values will remain unchanged. So, let us find more or less bright. So, more or less bright is here, more or less bright fuzzy set is here. So, what we are doing here is we had 1. So, we are taking the square root of 1 and then we are taking square root of 0.8, we are taking square root of 0.6, we are taking square root of 0.4, we are taking square root of 0.2. And this way we are getting, when we are taking square root of 1, we are getting 1, we are getting here in this case when we are taking 0.8 and then we are taking square root of 0.8, we are getting 0.8944. So, similarly, we are getting all these values when we are taking the square root, and this way we are forming a new set, and here we have formed a linguistic hedge. So, hedges are coming out of the modifications of the original or the primary fuzzy sets by adding the adjectives or adverbs. So, this way the bright fuzzy set is converted into the more or less bright. So, when we say more or less bright, it means we simply take the square roots of all the respective membership values which are characterizing the fuzzy set, this is discrete fuzzy set. So, that way we have understood as to how we manage to get the primary fuzzy set converted into the linguistic hedges. So, now let us understand here, move to the third class, and third class here is the negation, complement and connectives. So, when have been given a primary fuzzy set, a primary term, all these names can be interchangeably used, and when we try to find a negation of it, let us say we have a primary set, say middle edged, and then we say not middle edges, then how to get the not middle edges fuzzy set out of the given fuzzy set middle edges. So, here if I have been given any fuzzy set A, let us say A, the given fuzzy set, given fuzzy set, and this fuzzy set represents, this represents basically a primary set which is part of the term set. So, if we are interested in finding not of A, means as I mentioned, if A is a middle edged, then if we are interested in not middle edged, then we simply take the not of it, and not of it is represented by this sign here, not is represented by this sign. So, not is here, and not of A can be symbolically written like this, and what is done here to get not of A, we have already learnt this when we have studied, when we have discussed in the one of the previous lectures, the negation, the complement. So, what we do here is we subtract the corresponding membership values from 1, which you can see here. So, simply when we have been given a fuzzy set, let us say if I write the given fuzzy set A like this, if it is a continuous fuzzy set, we will be representing it like this, the integration sign, and then the universe of discourse just below it, and then mu of x and then x here. And then here what is done for not A is simply we take the complement of it, and when we take complement of it, the membership function is subtracted from 1, which you can see here, rest other things remain the same. So, this way we can get not this as the negation or the complement. And here in other case we can have the connectives like A and B. When we have let us say a fuzzy set A and fuzzy set B, both the fuzzy set have been given to you, then how to connect both the fuzzy sets together. For example, I can say middle aged and young. So, we have two fuzzy sets and both the primary terms are getting connected by AND. So, AND is here a connective. So, the connective can be either AND or, so these two are the connectives. So, here there could be A and B or A or B. So, like middle aged and young or middle aged or young. So, whatever way any two fuzzy sets can be connected. So, this AND can also be replaced by but. So, if we use but or AND, both are same. So, let us first take A and B. So, when we take A and B, so this means what? When we have already done this exercise in one of the lectures, previous lectures. So, when we have two fuzzy sets, let us say, and they are being connected by AND connective. So, we simply use intersection. So, A and B will become A intersection B, means both the fuzzy sets are being intersected, means we will have to take the intersection of the primary term set A and the primary term set B. So, this way when we do, what is happening with the corresponding membership function is this: we take the min of mu A x and mu B x. Similarly, when we connect A and B by AND, we take the union of A and B, and similarly we use the max sign in place of the min sign. So, here we connect both the membership functions of A and B like this, like mu A of x, and then we take max mu B of x, means we take max of mu A of x and mu B of x, which you can see here. And please note again that the generic variable values x will remain the same, will remain unchanged. Here these connectives are very interesting, and even negation also. So, negation and connectives both are basic connectives shown here, but since we have already done in the previous lectures that we have multiple kinds of negations, multiple kinds of connectives. So, like we could use for connectives various kinds of T norms and S norms. So, as and when it is required, we can use that also, but here if nothing is mentioned, then we simply use the basic S norm and T norms. So, S norm is used for OR and T norm is used for AND. So, this way the negation, complement and connectives can be managed, and this is quite interesting to note here that any primary fuzzy set, any primary linguistic value, when we say linguistic value is nothing but a fuzzy set. Linguistic value is represented by a primary fuzzy set. So, any primary term set, any primary fuzzy set, any linguistic value can be converted into its hedges, or in other fuzzy sets with negation or with connectives, we can manage to get a new fuzzy set. So, let us take an example here to understand the negation, complement and connectives. Here we have two fuzzy sets, both the fuzzy sets are discrete fuzzy sets A and B, and let us using A and B, let us find not A, and then let us find A and B. Here this is a connective, and in the third case also R is connective. So, and or both are connectives. So, let us now go one by one and try to find not A first. So, A has already been given. So, we represent not of A by negation A, and as I have already mentioned that simply when we have mu A, the membership function given, and then when it comes to negation of it, we subtract the membership values from 1, or if it is a membership function, we subtract this also from 1. So, when we do that, we get not A like this, means here we are negating all these corresponding membership values, and this comes out to be this. So, not A is this is represented by not A. So, a new fuzzy set not A given A is this. So, this way we find not A very quickly, very easily. Now, let us find A and B. So, A and B, as I have already mentioned that and is a connective, and is a connective. We have been given fuzzy set A, this is fuzzy set A first fuzzy set, and this is second fuzzy set. So, both the fuzzy sets have been given. Now, we have to connect these two fuzzy sets together, and as I have already mentioned that when we have and, we have to take the intersection of it. So, when we take intersection, the basic intersection uses the min. So, when we use this, we find the new fuzzy set like this. So, the new fuzzy set is with min of both the membership values. So, when we use this, the new fuzzy set is coming out to be this. So, we can say this fuzzy set is a new fuzzy set, new fuzzy set after connective and. So, this is for and. Now, if we use R, so R can also be very quickly managed to get. We see that here when it comes to R, means when we have two fuzzy sets and when we have to make a new fuzzy set by ORing both the sets. So, A union B gives us A or B, and here we use the max sign as a basic union. So, you see here the max sign, the inverted open triangle, and this way we have A or B, and this A or B is given here as after taking max of the corresponding two membership values, we are getting these values. So, the new fuzzy set which is coming after connecting A and B as R by R, we are getting a new fuzzy set here, the by R. So, R is the connective. So, this way we see that we have been able to manage to get new fuzzy sets. So, either taking the negation of the primary fuzzy set, or by connecting the two primary sets, or maybe even further we can connect two or more fuzzy sets by AND or 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 any other connectives, and we can get the expression for the fuzzy set. So, this way we are able to manage to get the new fuzzy set. So, with this I would like to stop here in this lecture, and in the next lecture we will discuss the concentration and dilation of linguistic values. Thank you.